Stealth technology isn't about true invisibility, it's about making detection extremely difficult. Imagine a high-stakes game of hide-and-seek. The goal is for a fighter jet to see its enemy first and strike before being seen. This is called low observability, reducing an aircraft's signature across radar, infrared, and even visual sensors. Radar is the primary detection tool. It sends out radio waves that bounce off objects and return to a receiver, revealing location and speed. Stealth aircraft disrupt this by deflecting radar waves and absorbing energy with special coatings, making them appear tiny or invisible on radar. This is known as radar cross-section reduction, or RCS reduction. But stealth goes beyond radar. Infrared sensors can spot engine heat, so stealth jets cool their exhaust and mask hot parts. Even noise and visual appearance matter. Special paint helps jets blend with the sky. The result? Pilots can penetrate enemy territory, strike high-value targets, and control the engagement, often before the enemy knows they're there. This first look, first shot, first kill advantage is why nations invest billions in stealth. Stealth has shifted air combat from open duels to ambushes from the shadows. It's a fundamental change in how wars are fought in the sky. Modern stealth means managing every signature: radar, heat, sound, and sight. The future of air superiority depends on mastering this art of near invisibility. That's why the world's top militaries are racing to perfect stealth technology. The stakes are high. Whoever controls the skies controls the outcome. Stealth isn't just a feature, it's a game changer. The next generation of air combat will be decided by who remains unseen the longest. In this new era, being detected can mean defeat before the fight even begins. The F-35 Lightning II is the product of decades of American stealth research. Designed from the start for low observability, it builds on lessons from the F-117 and F-22. Its all-aspect stealth means it's hard to detect from any angle, not just head-on. Internal weapons bays keep its profile clean, avoiding radar reflections from external stores. When ready to fire, bay doors open briefly, then snap shut, preserving stealth. Advanced electronic warfare systems add another layer, jamming or deceiving enemy radars. If its shape and coatings aren't enough, its electronics can still keep it hidden. This fusion of physical and electronic stealth makes the F-35 a nightmare to find and target. It's not just a stealthy jet, it's a complete, low observable combat system. That's why it's a cornerstone of modern air forces worldwide. The F-35's stealth starts with its shape, a masterclass in managing radar reflections. Every surface and edge is carefully angled to scatter radar waves away from receivers. Planform alignment means wings, tails, and fuselage are set at specific angles, minimizing radar returns. Sawtooth edges on doors and panels break up radar waves, diffusing energy instead of reflecting it. The canopy is coated with a transparent conductive layer, hiding the pilot and cockpit from radar. Engine air intakes use S-shaped ducts to block radar from seeing the engine's reflective fan blades. The diverterless supersonic inlet (DSI) design is lighter and simpler, further reducing radar signature. Even the engine nozzle is shaped to cut radar and infrared signatures. Every detail, from panel seams to exhaust, is optimized for low observability. The result, a jet that's nearly invisible to enemy sensors from all directions. Stealth isn't just about one feature, it's a holistic design philosophy. The F-35's geometry is its first line of defense. Shape is only half the F-35's stealth story, the other half is advanced materials. Radar absorbent material, or RAM, covers the jet, soaking up radar energy and turning it into heat. Unlike older stealth jets, the F-35's RAM is built into its composite skin, making it lighter and more durable. The special paint isn't just for looks, it's a multi-layered radar-absorbent coating applied with precision. Maintenance is critical. Even a small scratch can compromise stealth, so crews use specialized tools and procedures. Some coatings also help dissipate heat, reducing the jet's infrared signature. The exact makeup of the F-35's RAM is a closely guarded secret, constantly evolving to stay ahead of new radar threats. These materials are the invisible armor that keeps the F-35 hidden. As radar technology advances, so do the materials designed to defeat it. The F-35's skin is as much a weapon as its missiles. Stealth is a moving target, and the F-35's materials keep it one step ahead. For years, only the US fielded stealth fighters, but that's changed. China's J-35, also known as the FC-31, is their answer to American dominance. Designed for carrier operations, the J-35 marks a major leap for China's aerospace industry. Early prototypes looked rough, but recent versions show a refined, low-observable design. The J-35 is a twin-engine, medium-sized jet, similar in size to the US Navy's FA-18, but with stealth shaping. Its twin engines offer safety for long flights over water, crucial for carrier-based missions. The J-35 is expected to fly from China's new modern aircraft carriers, launching with heavy loads thanks to catapult systems. Its arrival is a game-changer. For the first time, US Navy F-35Cs could face a peer stealth fighter at sea. This shifts the balance in the Pacific, ending uncontested American air superiority. The J-35 is a credible threat, forcing new strategies and tactics. Its true capabilities are still debated, but its existence alone has reshaped military planning. China's commitment to world-class military power is clear. The J-35's debut signals a new era of competition in the skies. The J-35's design philosophy is clear. It borrows heavily from the F-35. Its chiseled nose, blended wing body, and angled tails echo American stealth jets. Physics dictates stealth shapes, so similarities are no surprise. Chinese engineers have applied the same principles: plan-form alignment, diverterless inlets, and internal weapons bays. The canopy is likely coated for radar protection, just like the F-35. But there are differences. The J-35 has two engines, resulting in two conventional nozzles. Scuba spots for radar and heat signature. Future versions may improve this, but for now, the rear aspect is less stealthy than the F-35's. Another question is the quality of China's radar-absorbent materials. The US has decades of experience perfecting RAM. China is catching up, but may not match American durability or effectiveness yet. Visible gaps and seams on J-35 prototypes suggest manufacturing isn't as refined as the F-35. The J-35's shape is stealthy, but the details matter. True stealth is more than just geometry. It's about materials and precision. The J-35 is a fast learner, but the F-35 still sets the standard. Comparing the J-35 and F-35, experts give the edge to the American jet. The F-35 benefits from decades of stealth experience and obsessive attention to detail. Its all-aspect stealth, advanced sensors, and electronic warfare systems are seamlessly integrated. Both jets are hardest to detect head-on, but the F-35's mature RAM and tight manufacturing tolerances likely give it an advantage. The J-35's twin nozzles could be a rear vulnerability, increasing radar and heat signature. In a dogfight, or while evading, this could be critical. Stealth is only as strong as its weakest angle. The F-35's radar can scan without being easily detected, thanks to low probability of intercept modes. The J-35's electronic systems are less understood. China is developing similar tech, but its sophistication is uncertain. Ultimately, the F-35's stealth is a complete system: shape, materials, and electronics working together. The J-35 is a formidable challenger, but the F-35's refinement sets it apart. In stealth, the smallest details make the biggest difference. The F-35's edge is in its maturity and integration. The contest is close, but the F-35 still leads. Comparing the F-35 and J-35 is challenging. One is well known, the other shrouded in secrecy. The F-35's capabilities are documented through years of testing and operations. The J-35, however, is mostly seen in photos and brief videos, leaving many questions unanswered. We can judge its shape, but not the quality of its materials or the precision of its construction. Key details, radar cross-section, RAM effectiveness, sensor capabilities, remain unknown. Chinese state media releases are often more propaganda than fact. Any comparison is based on educated guesses, not hard data. The J-35 could be more capable than we think, or it could have hidden flaws. Only real-world combat or detailed intelligence will reveal the truth. For now, the J-35 is a mystery, and the F-35 remains the benchmark. In the stealth showdown, the F-35 holds a clear, if narrowing, lead. Its design, materials, and systems are more mature, refined, and integrated. The F-35's all-aspect stealth and tight tolerances likely give it a lower radar cross-section from more angles. The J-35 is a major achievement for China, offering a credible challenge and forcing new strategies. But stealth is more than shape. It's about RAM quality, manufacturing, and electronic integration. Here, the US still has the edge. The J-35's rear nozzles may be a critical vulnerability. While the J-35 looks the part, the F-35 is likely stealthier across the board. The gap is closing, but decades of American investment still make a decisive difference. For now, the F-35 remains the king of invisible warfare.